Hello everybody, welcome to this class. Today we'll talk about verification and validation of autonomous system. Actually, in today's class, we just give an introduction to verify and validate your system. So in practical, we will see how we can verify the system using one of the formal methods, which is OOPO. So in today's class, we start with an introduction, then with the difference between the verification and validations. Then we will start with OOPO, which is one of well-known formal methods used for validate the system or used for modeling, validation, and verification of the real-time system. So in OOPO, we will we will see what the components of the overall, and we will look to the toolbox of Ubuntu. So let's get started. Unlike other systems, the safety in autonomous system actually is a critical issue and must be extremely reliable. And this because of the complexity of autonomous system, and also because its autonomous system actually is designed to deal with uncertain environments. So, unlike other systems, it's such as information system or other system which just receive an input and then they act based on this input. Autonomous system actually situated, so it should be able to interact with the environments, any environment that situated in the environment. So here we should use different methods to verify the system. So one of the well-known methods is formal verifications. And formal verification actually is used to verify real-time system by insistently testing all the possibilities of the system. So in practicals, actually, there is many tools that can be used for verify the system. So here in this class, we will talk about something we call it is OOPO to verify the system. So before we start, actually, the OOPO is a verification and validation methods for modeling the real-time system. So what the difference between the verification and validations? Actually, the verification, or the first we start with validation. Validation is check whether the specification capture the customer need. While the verifications, it's checking whether the software, the design of the software, it's meet these specification or not. After you design your software or the hardware, you need to check whether the software is meet the specification that developed in the elicitation step or not. So in this course, it can help to verify either your software or your design. Actually, as we said before, we go to the developing the design before we go to the prototypes. So we need to check either our software is meet the specification or not. So here's some example of the real-time system. So in the real-time system, also the other like pump control, some example of the also the airbags, robots, ABC, anything it's made the faults is not depends only on the design or in the logical design of the system, but also on the timing. The system or the design of the system is not only depends on the logical design, it's also depends on the timing, depends on the interaction with other parts of the environments. So what's the verification? As I said, the verification is we want to ensure that the specifications or the software design meet the specification. So the verification is the process of confirm that the design satisfy the system requirements. Okay, now if we say why we need, if we have testing, why do we need another methods or another tool for verifications? So why do we need the verifications? Since we have another tool like software testing. Software testing, we can test the software and then done. No, actually software testing, mostly we just generate some representative tools or representative input and output test cases. So the verification is different. The verification is they try to exhaustively test all the possibilities. Verification actually there is some properties need to be checking. For example, the correctness, the reachability of some points or so. In the verification, we check all the possibilities of this property. But in the software testing, we just check some, as we say, representative of the test cases. Maybe the total or the exhaustive testing, for example, 1 million, but we check only 20 test cases of this 1 million. So in the formal verification, the tools that use is try to check all the possibilities and try to cover all the test cases that we need to check a specific property.